A very good morning, sir. This is Muhammad Hani from CSCB section, and the topic for my presentation is BCNF, 4NF, and 5NF. So, moving towards the introduction to normalization. Normalization is a process used to minimize redundancy and dependency in database design. It involves organizing data into tables and defining relationships to improve data integrity. Understanding BCNF, 4NF, and 5NF is crucial for achieving optimal database structures. See here, what is redundancy? Redundancy is something like when in some particular tuples, there would be the repeated values. Due to these repeated values, the tables become complex, which is in turn called as redundancy. And what is dependency? The dependency of each column onto the other column is called as dependency. So to reduce these redundancy and dependency, we use normalization. And one such normalization is BCNF. BCNF is actually the boys code normal form, which is an enhancement of the third normal form. It is like advancement of third normal form. A table is in BCNF if it is in 3NF, and it every determinant is a candidate key. So here, what is candidate key? A minimal super key is called as candidate key. What is a super key? Super key is a set of all like unique and not null set of columns are called as super keys. And what is candidate key? Minimum super key is called as candidate key. Like in BCNF, it should be in 3NF, and also the determinant should be a candidate key. This ensures that there are no trivial functional dependencies that violate the key structure. And what is the importance of BCNF? BCNF eliminates redundancy and prevents anomalies during data operations like insertions and deletions. See here, BC, as we discussed, it eliminates redundancy. Actually, it minimizes the redundancy and prevents anomalies like insertion anomaly, updation anomaly, deletion anomaly. These anomalies will also be prevented by this BCNF. It strengthens the database design by ensuring that all functional dependencies are based on candidate keys. Adhering to BCNF can lead to more efficient and reliable database system. And now let us move on to the example of BCNF violation. Let us consider a table where a student's ID, course ID, and instruction ID are stored. See in this table, you can see the SID, major, advisor, major's GPA. If the instruction is determined by the course ID, then the table may not be in BCNF. As we could see in the table, the advisor is same for both physics and there are same subject, whereas the student is 123 and 678. See, for both the students, the subject is the same and the advisor is also same. But the only thing is we are actually making it into the complex table. So to reduce this redundancy, we use this BCNF. As we move to the next slide, what is 4NF? 4NF is a fourth normal form, addresses multi-value dependencies that can occur in a database. A table is in 4NF if it is in BCNF and has no multi-value dependencies. This ensures that each attribute in the table is dependent on the primary key only. See, as we could see in the fourth normal form in the first table, the textbook author is same for second and third tuples. As you can see in 2 and 3 tuples, management. This ensures that each attribute in the table is dependent on the primary key only. As we could see in 2 and 3 tuples, both have the same textbook authors. It actually increases the redundancy. Like to reduce this redundancy, we are splitting it into two different tables. Importance of 4NF. 4NF actually eliminates the redundancy caused by multi-value dependencies, since we have seen in the last example that they are used to eliminate the redundancies and dependency, multi-value dependencies, and it helps maintain data integrity by ensuring that no trivial multi-value dependencies exist. This normalization form is particularly used in scenarios where attributes can have multiple values, as we have already seen in the example. That is what here they have mentioned. And moving on to the next slide, example of 4NF violation. The fourth normal form violation is a table that stores students and their hobbies and their skills. As you could see in this example, if both hobbies and skills can have multiple entries for each student, it creates redundancy. See, one student can have many hobbies and many skills. Like for this reason, we cannot go on adding a number of tuples, like which becomes in turn becomes the complexity of the table. So this in turn creates the redundancy. So we have to eliminate this type of redundancy by using this fourth normal form. Fourth normal form. Now, what is 5NF, fifth normal form? It is also known as project join normal form, which focuses on eliminating the same thing, the redundancy caused by here. In the last fourth NF, we have seen multi-value dependencies, but here it is join dependencies. A table is in 5NF and it is in 4NF. See, whenever it is in 4NF, then 5NF and it does not contain any join dependencies, then only you can say that it is in fifth normal form. This ensures that all information can be reconstructed from smaller tables without losing any data. Once we see the example, we'll understand it better. And what is the importance of 5NF? 5NF reduces the complexity of the database structure by eliminating unnecessary join dependencies. See, in some tables, we use cross join, natural join in order to join those two different keys. So, in this, it creates a complexity, it creates redundancy by removing this unnecessary join dependencies. Then we could say it is in 5NF, and it enhances data integrity by ensuring that all data can be constructed accurately from smaller related tables. Adopting 5NF can lead to a more efficient database design, especially in complex scenarios. And coming to the end, that is the summary and best practices. BCNF, 4NF, and 5NF are essential for creating a well-structured and efficient database. Implementing these normalization forms can significantly reduce data redundancy and improve integrity. Database designers should carefully evaluate the need for higher normal forms based on complexity database relationships. So, finally, this is what the summary, like using these all BCNF, 4NF, and 5NF and other normal forms as well, we actually reduce the redundancy, and which actually reduces the complexity of the database relationships. And this is what database designers concentrate on, so that they could be reliable, they could be compatible in every system. And that's all for the presentation. Thank you for your patience listening.